Pluto is far away from the Sun, of course, so the Sun is multiple times fainter than it is here on the planet. So, its freezing temperatures decrease to around -230 degrees Celsius during the evening time. In an intensity wave, you could get as high as 170 degrees Celsius. It has an exceptionally questionable environment too. Welcome inquisitive personalities to an investigation past the recognizable domains of our solar system. Consider the possibility that I let you know that Pluto, the far-off and confounding bantam planet, is at long last taking its infinite action, possibly crashing into none other than Neptune, the ice monster. Pluto's defiant nature has been obvious from the start, a rebel on the edges of our heavenly area. Its circle daringly running into another planet challenges the ordinary standards of planetary conduct. I imply that is no sort of direct for a planet, right? From the confounding complexities of Pluto's circle to the raised worries voiced by astrophysical illuminators like Tyson and Kaku, a waiting inquiry hangs in the vast equilibrium. Will these divine monsters take part in a crash course? Could the intermingling of their ways spell unanticipated ramifications for our darling planet Earth? Today we set out on a vast excursion loaded up with vulnerability. While the solutions to these heavenly inquiries might escape us right now, the potential for a crash of such infinite extent fills in as a distinct update that the universe is a stage for occasions both remarkable and perhaps address the startling side. Go along with us as we dive into the secrets that circle how we might interpret Pluto and Neptune, examining the possibilities of a heavenly conflict that could reshape the infinite equilibrium of our nearby planet group. The stage is set, and the unfurling show coaxes us to witness the baffling dance of the planets among other potential space catastrophes. The universe harbors a variety of riddles, and among them is the multifaceted riddle known as the three-body issue. Yet, researchers anticipate other expected calamities inside the heavenly theater. Although a planet crashing into one more in space is exceptionally unlikely, it isn't thoroughly out of the inquiry. Gravitational connections, as portrayed by the three-body issue, are one of the forces that influence planetary circles. An illustration of a space framework where gravitational powers produce an intermittent example known as orbital resonances is TRAPPIST-1, which has 7 planets the size of Earth. As time elapses, these examples could debilitate planet circles, improving the probability of crashes. What is happening does exclude any impacts, despite the fact that frameworks, for example TRAPPIST-1, are very thick and planets influence one another's courses, particularly when they are close. Researchers consistently screen these frameworks to figure out this. With this data, we can more readily figure out how the planets travel through space. Another obscure realized part is maverick planets, which float erratically in space rather than encircle around a star. Ejection of planets from star frameworks can happen as a result of gravitational posts or other galactic peculiarities. For example, another star's nearby methodology or dynamic unsteadiness in frameworks with more than one planet. Over the long haul, these meandering planets can travel perfect removes, potentially in any event, arriving at regions a long way from where they started. It is conceivable that they will encounter other star frameworks on their performance journey. The probability of a planet crash increments in the event that one of these planets goes to another nearby planet group. In any case, a maverick planet striking another planet head-on is very far-fetched. Taking into account how tremendous and for the most part unfilled space is, the sparsity of planets in open space and the vastness of interstellar distances cooperate to deter continuous impacts. It is as of now profoundly improbable that 2 rebel planets will impact, however. The recurrence of rebel planets is far lower than that of stars and planets in stable circles. The star frameworks included can become tumultuous in the occasion of a cosmic consolidation. It is profoundly unrealistic that planets will impact head-on during these enormous occasions due to the huge interstellar distances. The circles of stars and planets with emerging systems are modified decisively by major areas of strength for the gravitational forces. A planet might turn into a rebel world liberated from any star. At the point when this sort of mayhem drives it out into the virus dark profundities of intergalactic space. Then again, planets could be ousted from their circles, slam into each other, or even influence their host stars because of these gravitational unsettling influences. When gas and residue are packed under very high tension, gravitational revision can really cause new heavenly bodies to frame or maybe begin stars to arise. In our solar system, the late weighty assault proposes that around 4 billion years prior, there was a time of expanded impacts, including comets and space rocks. This flood in Devil Act is accepted to have come about because of gravitational aggravations brought about by the outer planets. During this tumultuous stage, gas Goliaths like Jupiter and Saturn were going through relocation, disturbing the circles of various more modest bodies in the Kuiper Belt and Space Rock Belt. As a result, these more modest items were tossed into capricious ways, with many evolving into the inward nearby planet group. This flood prompted a critical ascent in influences on the earthbound planets, including Earth. While these crashes didn't include direct conflicts between planets, they outline how gravitational communications can achieve significant shifts in the directions of heavenly bodies. This assault is thought to had an essential impact in molding the surfaces and land narratives of planets in our planetary group. Furthermore, it might have added to the conveyance of water and organic materials to Earth, affecting the advancement of our planet over a lengthy period. As stars go through changes in mass streams, then, at that point, portions of planets around them might wind and possibly cross. This is particularly perceptible in frameworks where stars are toward the finish of their life cycle. As a star advances in years and consumes its atomic fuel, it frequently goes through huge mass changes, particularly during stages like the Red Goliath stage or, on the other hand, when it discharges material in a planetary cloud. These varieties in heavenly mass can altogether affect the gravitational equilibrium of the framework, making the circles of adjacent planets either move outward or become more compacted. This is bound to occur in multi-star frameworks where complex gravitational collaborations can without much of a stretch lead to unsteady circles. In such frameworks, the gravitational forces from numerous stars can cooperate capriciously, intensifying orbital shift and expanding the possibilities of circles meeting. This can result in circumstances where planets could get caught by another star, slam into other divine bodies, or even get catapulted into interstellar space. Pluto's novel circle, at first recognized as an undeniable individual from the planetary family, went through a renaming, eventually being designated as a Bantam planet inferable from its unmistakable circle. The astronomy local area is as yet enchanted by it and finds it captivating even with this alteration. There's reason to worry as to closeness of Pluto's track to Neptune's. As indicated by recent forecasts made by prominent researchers like Neil deGrasse Tyson and Michio Kaku, these researchers are sounding the alert about a grave danger to Earth, the plausibility of an impact between the planets. Pluto is not normal for some other planet in our planetary group, and this is what makes its circle around the Sun so one of a kind. Pluto has not completed a full unrest since its discovery in 1930, and its circle ranges an extended 248 years. The reality that it goes astray altogether from the generally round circle of the huge planets makes its course incredibly curved, further adding to its quick motion. Pluto likewise has a more severe circle than different planets because its tendency to the ecliptic plane is 17 degrees. Adding unpredictability to Pluto's orbital example is the blend of its curved structure and tendency. The point where Pluto's circle runs into each other with Neptune's is an interesting component. During around 20 years in each circle, Pluto adventures nearer to the Sun than Neptune, testing assumptions in view of their particular situations in the nearby planet group. This prompts the inquiry: why hasn't a crash among Pluto and Neptune happened? The clarification lies in the gravitational impacts applied by different planets. The assessment of Pluto's circle began not long after its discovery, introducing a perplexing direction for stargazers. Not at all like the larger part of planets whose circles align relatively near the ecliptic plane, Pluto's particular elements incorporate a steep tendency and a circular shape. The mystery extended with the acknowledgement that Pluto's circle crosses that of Neptune, the three-body issue. Pluto's circle stays stable in the midst of the complexities, filling in as a demonstration of the inborn intricacies of divine mechanics. Embracing the movement and gravitational communications of three brilliant bodies like Pluto, Neptune, and the Sun is known as the three-body issue in space. Anticipating their directions from their beginning positions and the impacts of gravity on each other is comparative for Pluto. Some of the terms that assist us to address this cosmic secret are azimuth libration, scope libration, and the VZK swaying. As indicated by astrophysicists, Azimuth libration is essential, since it keeps planets in their circles when Pluto crosses Neptune's circle. It is no less than 90 degrees far off, which is a critical distance that forestalls crashes. This definition, applied to Pluto and Neptune, scope libration alludes to the upward development of a heavenly body in its circle, guaranteeing that when Pluto approaches Neptune or other monster planets, it is arranged fundamentally over their orbital plane, giving an extra layer of security against crashes. A vital figure in understanding divine movement is the VZK wavering, named after three researchers, Van Lee and Kai. They investigated the gravitational connections between three space objects, for example, Pluto, Neptune, and the Sun. The VZK wavering makes sense of why Pluto's circle around the Sun seems abnormal yet stays smooth over the long haul. Regardless of the obvious haphazardness in space, basic examples and rules keep everything under control. These factors, by and large, settle Pluto's circle, preventing impacts with Neptune or deviations from its course. The three-body issue assists us in understanding how the gravitational PS of these space objects impact their way. Contemplating this adds to our knowledge of Pluto, our planetary group, and far-off heavenly bodies. Mathematical recreations in the last part of the 1980s uncovered that, in spite of stable properties, Pluto's circle is actually tumultuous, with minor beginning deviations prompting huge contrasts north of millions of years. Circle stability notwithstanding, Pluto's uncommon circle displays momentous stability over broad periods, really alleviating possible tumult. Late programmatic experiences have expanded our appreciation of the many-sided elements, including huge planets like Neptune, Jupiter, and Saturn, impacting Pluto's direction around the Sun. Neptune's particular gravitational impact, finishing 3 circles for each 2 of Pluto, fundamentally adds to the overall security of Pluto's orbital way. Jupiter's gravity is likewise significant, though less so than Saturn's. Taken as a whole, these observations illustrate that Pluto is in secure and consistent movement across space over billions of years. It is ensured by the joined impact of Jupiter, Saturn, and Neptune to keep the movements of divine bodies in the universe ordered and unsurprising. These events are fundamental. In the absence of these systems, the solar framework would be more turbulent and erratic, improving the probability of impacts and discharges from generally consistent courses, which may have extensive ramifications for other heavenly bodies. Considering later hypothesis regarding an inevitable crash among Pluto and Neptune, it is fundamental to grasp Pluto's circle. With this data, the ever-changing nearby planet group might be better gotten a handle on. The instance of Pluto delineates how the complex association between orbital mechanics and gravitational powers may make clearly unstable circles accomplish harmony. To more readily comprehend our spot in the universe, it is significant to persistently notice and dissect these occasions. Space investigation frequently uncovers the unpredictable behavior of magnificent bodies. Pluto's circle is an exemplary delineation of this unpredictable conduct. The case of Pluto gives a striking representation of the possibility of orbital disarray, which shows how the direction of a heavenly body is profoundly subject to its beginning stage. Minor changes in the Bantam planet's area or speed can immensely affect its orbital way. Long-term researchers' comprehension of Pluto's movement in space is for the most part because of virtual experiences. In request to reproduce the gravitational communications among Pluto and other planetary bodies like Neptune, these reenactments utilize unpredictable numerical models. Space experts can see how small changes can essentially influence Pluto's way by controlling the models. These models revealed a fascinating piece of Pluto's direction. In the last part of the 80s, the circle of Pluto can still be fairly erratic even, however, it is balanced out by highlights like AM suppress and scope libration. When Pluto's situation or speed is fairly off from the very outset, it can change its course fundamentally throughout the span of quite a long while. Even while Pluto's circle is innately tumultuous, it stays stable for quite a long time, billions of years. This recommends that underneath its apparently unpredictable appearance, Pluto's excursion around the Sun follows an organized request, foreseeing infinite occasions. Particularly with planets like Pluto that have capricious circles is very testing. The innate unconventionality of these frameworks makes long-haul gauges dubious. Mathematical reproductions assist us with understanding and expect the future ways of divine bodies, yet they likewise uncover the limits of our prescient capacities. These models intensely rely upon exact introductory conditions and recreate complex collaborations. Even a small mistake can lead to altogether various results, making exact forecasts troublesome. The tumultuous nature of divine circles such as Pluto helps us to remember the ever-changing universe. While we've gained ground in understanding space, Pluto's case features our continuous limited information. Understanding the gravitational impacts of monster planets on Pluto's circle gives significant experiences into the more extensive elements of the planetary group. It shows how every planet's presence and position can influence the security and direction of different bodies in the framework. Concerns of an expected crash, Neil deGrasse Tyson, an eminent astrophysicist, crucial in promoting cosmology, offers a particular viewpoint on the riddles inside our nearby planet group, especially zeroing in on Pluto. Tyson, prominent for renaming Pluto from an undeniable planet to a smaller person planet, shares canny reflections on the developing idea of our comprehension of heavenly mechanics and humanity's persevering interest with the neglected domains of space. As opposed to viewing Pluto's renaming as a downgrade, Tyson considers it to be an important change, lining up with the extending information about the hoard objects circling the sun. His way to deal with heavenly repairmen revolves around ceaseless learning and variation. Tyson sees the complexities of circles exemplified by Pluto's exceptional way as a steady sign of the tremendousness of information ready to be uncovered in space. He states that the emanation of these inestimable questions is the main thrust behind the enthralling nature of space science. Tyson additionally recognizes the essential job of space-related occasions and revelations in molding public interest in space science. He considers occurrences like Pluto's renaming and its whimsical circle as any opportunities to light the public's creative mind and interest in the universe. By digging into the dynamic and sometimes nonsensical aspects of room mechanics, Tyson opens an entryway for the overall population to wonder about the miracles and secrets of the universe. Working close by different researchers, Tyson has effectively advised people in general about the expected risk of Pluto's erratic way. Subsequent to concentrating on Pluto broadly, he has raised worries that the three-body issue could represent a genuine danger, suggesting that a crash with Neptune is very much past due. Also, he underscores how such an impact could upset the equilibrium of the universe and lead to horrendous results. Reaching out to Earth, a crash between Pluto and Neptune would be a strange and devastating occasion in our solar framework. This impact would deliver a gigantic measure of energy, probably breaking separated Pluto because of its more modest size and frigid organization. Garbage from the impact could dissipate across the solar framework, presenting expected risks for different planets and their moons. For Neptune, such an effect might actually change its environment and circle, depending on the particular subtleties of the crash. Michio Kaku's point of view, a recognized hypothetical physicist prestigious for his commitments to string hypothesis and science advocacy, brings an unmistakable point of view to the unfurling situation. His insights into the fate of room investigation and the intrinsic association between heavenly mechanics and hypothetical physical science offer significant reflections on peculiarities such as Pluto's circle. Kaku sees the investigation of Pluto and its circle as a window into the planned domains of room investigation. As per him, disentangling the complex gravitational connections and orbital elements of heavenly bodies exemplified by Pluto gives important experiences for impending space missions. This obtained information becomes instrumental in exploring the solar framework, adroitly anticipating potential risks, and decisively arranging missions to the external ranges of our nearby planet group and past. Highlighting that illustrations extricated from the investigation of Pluto's circle can act as a diagram for drawing closer and understanding other far-off heavenly bodies, Kaku underlines the more extensive uses of this information in his conversations on planetary physical science. Kaku reliably highlights the significant interconnection between heavenly mechanics and hypothetical physical science. He battles that the developments and collaborations of planets, for example, the gravitational dance among Pluto and Neptune, aren't detached events yet rather unpredictably attached to basic principles of physical science. Kaku's interests in hypothetical physical science, especially in the domain of string hypothesis, intend to understand these principles at the most major level. He places that diving into the intricacies of divine mechanics exemplified by the circle of Pluto has the possibility to disclose bits of knowledge into the hidden regulations overseeing the universe. Like Tyson, Kaku digs into the inestimable probability of an impact, consistently meshing it into his more extensive hypotheses about the universe. If Pluto and Neptune were to impact, it would be a huge occasion in astronomy, offering a unique observational opportunity that could possibly add to our comprehension of string hypothesis. String hypothesis, a hypothetical structure replacing point-like particles with one-layered strings, looks to portray the key powers and matter in the universe. A crash of such size would provide invaluable data for refining and testing the predictions of string theory. Kaku's perspective underscores the interconnectedness of celestial mechanics and theoretical physics, highlighting how events such as a potential collision between Pluto and Neptune serve as opportunities to deepen our understanding of fundamental principles governing the universe. In conclusion, the intricate dynamics of Pluto's orbit, alongside the perspectives offered by astrophysicists like Neil deGrasse Tyson and Michio Kaku, underscore the complexity and significance of celestial mechanics. Pluto's erratic path, potential interactions with Neptune, and the broader implications for our understanding of the cosmos highlight the ongoing quest for knowledge in the field of astronomy. Through continued observation, mathematical modeling, and theoretical exploration, we strive to unravel the mysteries of the universe and gain deeper insights into the fundamental forces that shape our cosmic environment.